Congratulations everybody, you have successfully completed the bulk of your OSPF training. As you can probably tell, there is no slide. I have the topology and our Super Putty configuration up and running. So what does that mean for you and I? That means for you and I, we're going to go through and do some of the corner case stuff that isn't specifically listed on the exam, but I think is still valid to know. There's a few of them in here that we work on. And the first thing we're going to take a look at is trying to filter routes out, the different ways you can do that. And the first thing we're going to do is we're going to take a look at doing Type 3 LSA filtering, which means it's going to be inter-area routing that we're going to filter out, which means that it's not going to be a summarization to where it's still reachable. It's going to be completely gone. We're also going to take a look at using distribute lists, calling for prefix lists, and see exactly how that works, and then go from there. There's not a lot that we're going to cover, but the bulk of it's just going to be manipulation of how traffic should go, and just be aware that all the different techniques that you can use for either filtering or summarization or things like that, default routing if you will, you can use these things for traffic engineering. Now when you hear the term traffic engineering, you should you may or may not, because of your level of understanding or your exposure to real production environments. When I hear traffic engineering, the first thing that comes to my mind is how do I manipulate the traffic to go where I want it to go? Now, you could, if you wanted to, do a thing with like policy routing, to where you were going out and you are routing based off of source-based traffic and setting the next hop accordingly, which we'll take a look at that coming up here in an upcoming video. It's more of a corner case routing scenario, but it still does take it still does have some sort of validity. The other ones that are out there that are available are going to be longest match routing, which means you simply go out and you affect the how long of a match a particular router advertises. And this way here you're able to say, okay, dynamic routing, or routing in general I should say, it routes based off of longest match. So it'll look in the routing table and say, okay, which path has the longest match? Because the longest match is supposed to be the more specific route. And if I have a /26 versus /22, I'm going to /26. And if the /26 goes down, I'm going to fail over to /22. And that's usually how you can get things to that's how you can affect your routing based off of that. You could also go in and completely remove a route or filter the capability of a route being advertised. So for instance, if we wanted to prevent, like for instance right now 11, if we were to do a trace route to router 2, we go out router 4. Well, let's say we want to prevent that from happening. Well, we could do a distribute list out and say we don't want to have, we don't want to route that out. We could set this up as a passive interface. Passive interface in OSPF has the exact same effect as a passive interface in EIGRP. It simply stops sending and receiving hellos, so that no adjacencies can form. So there's multiple aspects to how you can make this work. Where we're going to focus here is we're going to go into router 5, and we are going to prevent router 4. If we come back over here to router 4, if we jump over here and do a show IP route, we are going to prevent router 11 and 12's Type 3 LSAs from being aggregated to this area. We don't want them to be learned from router 2, or we don't want anything in area 2, 3, 4, 5 or 124 to learn anything to learn router 11 or 12's loopbacks. Sounds pretty straightforward, right? Well, there's a couple ways. The key thing to remember here is that when you're dealing with this, you're going to be dealing with an inter-area route, which means that you're going to have to make sure that you place it accordingly so that the OSPF routing process will see it coming inbound or going outbound as a Type 3 LSA. Now that's the caveat here. If it's going to be in area 100 and you're going to area 2345 or area 0, what happens when router 5 takes a Type 1 LSA from his local area 100 route and he moves it to a different area? What type of LSA does that get originated as? Type 3, right? Inter-area, summary network link state. Well, that's what you need to make sure. You have to go to the area-specific information and make sure you apply it correctly there. So what that means is we were to go to router OSPF 5 and type in area 0 question mark. We have this filter list capability. Okay, and this is going to be filter networks between OSPF areas. So we type in filter list, and we're going to say prefix. And we're going to create a prefix list here in a minute. I just want to say this is going to be area 100 and question mark and hit inbound. Now, why inbound? Well, if we're in area 100 and router 5 is in area 100, the loopbacks that 11 and 12 are advertising are in area 100, what kind of LSA, what type of LSA is going to be originated at type 5 from 11 and 12 for their loopbacks? Type 1, right? Which is going to be a intra-area LSA. Same thing with type 2 LSA. It's an intra-area LSA. Those are the only two LSA types that you will see in an intra-area routing. Type 1 and type 2. You won't see, unless you're doing some sort of, unless you're doing point-to-point routing, and you remove the, if you're using any flavor of point-to-point, you remove the type 2 LSA because there's no DR-BDR election involved. So when you're setting this stuff up, you need to make sure that if area 100 and area 0 and area 2, 3, 4, 5 are all on the same router, which is router 5, they're all they all terminate, or at least have a link in that area, then I would have to specify the area the routes are going to be going into and where the routes are becoming inbound to. So what that means is if area 0 is going to receive those routes from area 100, they're going to be translated from type 1 to type 3 because an area, or router 5 is an area border router. So this means I have to go in there and I have to say when routes are received inbound on area 0 and they match the prefixes in the prefix list area 100, I'm going to filter them out. Now it would be the other way around if I had router 3 was going to be sending traffic from area 0 to area 2, 3, 4, 5. Now if router 3 wanted to prevent router 5's loopback, I'm sorry, let's say let's say that router 11 is advertising another route. Or let's say, for instance, router 2 is advertising, or no, they're all in the same area. We'd have to do it on a different router, but the idea is if you want to, I was trying to think of a good way to explain that. So let's say that router 1 advertises a route that's inter-area specific. Router 5 receives that because it can't be on a directly connected, or it can't be on an area border router that's in the same area as the originating router because then it's intra-area. So it's type 1 LSA. On router 5, if router 5 was to receive a route from router 1, it's going to be a type 3 LSA because it's inter-area. Then I can say outbound into area 100. And what that would do is that would filter the routes out from going out towards router 11 and 12. So here's what we're going to do. Question mark, and then that's all there is to it. We're going to do this. Now what we're going to do is we're going to exit out of here. I'll type in IP prefix list, area 100. And I'm going to say permit. And I'm going to say, I believe it's permit. I'm going to permit 10.255.11.11/32, and same thing with 12.12/32. Okay. Now by setting this in, now I'm not 100% sure if it's supposed to be permit or deny, but what I'm going to do is this is going to be inbound area. This is area 0 receiving the routes from area 100. So I'm going to go to router 3 then. And I'm going to say on router 3. Notice how we have the routes right here. 11's there, 12 is there. Let's see if that actually took effect. It did not. So I have to adjust that configuration. So it's actually not going to be. I'm going to say no. Hit the up arrow, and I'm going to slap a deny. because I couldn't remember off the top of my head. I wanted to test it out before I did that. So let's go to 3, hit the up arrow, and now 11 is gone. See that? Go to 5 again, hit the up arrow, go to 12, type in no, hit the up arrow, pull the permit out, replace it with the deny, and then go back over to 3. Whoop. Click on 3, hit the up arrow, and now 12 is gone. Okay, so I have no inter-area routes from there. That's inbound into area 0. Now, but if we go to 4 though, and hit the up arrow, they're gone as well. Okay, so I wasn't sure if that was going to be the case or not. I had to double check. But that at least shows you how that would work. Okay, so now that's inbound. Now let's test it outbound. Let's go to router 1, and we're going to type in, I'm going to advertise a loopback, so I'm going to type in do show IP interface brief. I want to make sure that I'm not using a loopback that's already in use. So interface loopback 100. IP address is going to be 10.100.1.1/24, and I'm going to do 101, and it's going to be 101, and so on and so forth. So I'm going to type in do show run pipe section OSPF, and I want to make sure that if I have a network statement that's going to encompass that. And I do. So now I can go to router 5 and do a do show IP route. I should have 10.100, 10.101, and 10.100 coming in. And if I look in router 4, I should have them coming in there as well. But they're intra-area here. They are inter-area here. So I want to prevent them from being advertised to router 12 and 11 and 12. So here again, I'm going to type in IP prefix list. I'm going to type in area 2345. I'm going to type in deny, and I'm going to grab the route here. Deny that, /32, and deny 101. Type in router OSPF 5. Type in area 100 filter list prefix to area 2345 out. Okay, now if I go to 11 now, and if I hit the up arrow, I may not have come through yet. So the routes are there. It might not. Because the fact that these guys are coming across the frame relay, it might take a couple seconds. So let's do a clear IP route star. They're still there. Well, I did a little bit of checking and my configuration's right. I just don't know why it's not working outbound. So let me just tweak this here real quick. I think I'm going to be getting a new mouse soon because this thing just keeps bugging out on me. Type in no, or I'm sorry, you know what? Sorry, it's not area that one. It's area 2345 because they're not. It's area 2345 they're coming from. So that might help. So let's go down to 11 now and hit the. Let's do a clear IP route star. No, I don't think that's the problem. Where am I learning the route? So do show IP OSPF database area 0. Oh, you know why? Because I'm learning it for multiple areas. That is why. Let's see here. I'm gonna do it on router 5, but I'm gonna do it inbound on area that one as well as area 0. And now if I go to 11, that should fix it. There it goes. So that was the problem. Because the fact that, and I'm actually filtering more than I need to be. But that's why it was doing what it was doing, because the fact that it was learning it for multiple areas. and that was my bad. But the thing that one thing I don't know if you noticed this or not, but we lost a bunch of routes. So the problem with this config here with our prefix list, but I've been do show IP prefix, you'll see that I've got just this in here, right? I don't have anything else allow through. So what I need to do is I need to type in IP prefix list area 2345 this and type in permit 0.0.0.0/0 LE32. Now if I go back to 11 and hit the up arrow, now we should, as soon as routes are able to propagate, we should have a bunch of other routes coming through. And the reason for that is because it was filtering everything, not just those routes. So if we go to 12, the same thing. So we hit the up arrow, we should have a bunch of those routes in. They just came in a propagation, but we don't have the 100 routes in there, which is what we were looking to filter out. So that's one way. The other way is through distribute list. So let's go to router 3, and I'm going to go to global config. Now the distribute list is a way for you to filter traffic inbound and outbound via the any route. So the filter list is type 3, and technically in this case it was advertised. It was actually filtering out more than type 3. Or actually no, let's go back to. It was filtering out type 3 LSAs. As you can see, the E2 routes are still here. So it filtered out type 3 LSAs. So no type 3 LSAs were able to be advertised, which is what we accomplished that goal, right? And we did that by going outbound. And I think I used the inbound command, outbound. So we successfully used out as well. So what we have to do now is we want to filter other specific routes. So let's say, for instance, on router 3, keep doing that. On router 3, if I do a show IP route, let's see what else we can filter here. If I want to filter out this route right here. So if I want to prevent that route from coming in, I can do that as well. So what I will do is since I've got the syntax in here, I'm going to go to global config, type in IP prefix list external, and I'm going to say deny, and I'm going to right click and paste that guy in there. And I'm going to do that. I'm going to hit the up arrow, but I'm going to go in here and type in all zeros /0 LE32, which is going to permit everything else. And I'm going to type in router OSPF 3. I'm going to type in distribute list prefix list, and the name of the prefix list is external. And I'm going to prevent that from being learned to inbound. And that's going to take care of that. So now if I type in do show IP route, I should no longer be learning that route. As soon as everything, let's see here. That filtered everything. So I think I might be a little broad on that, but that's not okay. But I don't know why that filtered everything out. Interesting. And the filter is allowing everything through. Oh! Goofy. You guys are like, you don't have your configuration right. You are absolutely right. Permit. Actually, let's actually do this. I'm going to grab this command, and that was the problem. I'm glad I reviewed my configuration. It didn't even dawn on me to double check that. I'm going to do this right here. Pull this deny out. That's why it's not working. Type in no. Right click on that guy and type in, hit the up arrow, pull this guy out, I'm going to type in permit. And then go type in do show IP route, and voila. Now we have more routes, but we're only learning in this route. We were before learning in both routes. Now we filtered that guy out, which is what we were trying to accomplish. Now you can do this with route maps and other capabilities, but that's a general idea with how your configuration should be set up. You should know how to do type 3 LSA filtering, distribute list out, or distribute list in. So let's take a look at a distribute list out. So let's say here, router 3, we're going to say here, we're going to do a show IP route. show IP interface brief, and I'm going to create a that was a distribute list in that I did. I'm going to distribute list outbound, and I'm going to type in interface loopback 100, IP address of 10.200.3.3/24, and I want to prevent that route from being advertised outbound. I want it to stay local to my box. So I want to prevent this route from being propagated outbound. So I'm going to exit out of here and type in IP prefix list, no out, and I'm going to type in deny this IP address /24, and I'm going to type in router OSPF 3 distribute list, and we're going to type in prefix list, no out, no, and then outbound. Now gateway will be filtering incoming updates from a particular gateway. So that means, and I will show you what this means here in a second, if we were to do a quick do show run pipe section OSPF, I want to make sure that I'm actually advertising that route, because me filtering it and not advertising it is not accomplishing the same goal. So I'm going to type in network of 10.200.0.0. Not advertising the route into the area wouldn't accomplish anything. So I want to make sure that I'm advertising the route, and so it is, type in do show IP OSPF interface brief. This will tell me that I'm actually advertising on that subnet. And if I go to router 2 and do a show IP route, I should not be seeing the 10.200. Let's see here, 5. Or I'm sorry, 3, not 5. Let's see what 5 is learning. Do show IP route. I'm learning the route in. You know what? I might not be specific enough. But I've got it to /24, so it should be enough. But I'm not sure why. Let's take a look at this. So let's see. Let me try doing it this way real quick. Let's go to that prefix list, and we'll make that prefix list just a little bit more straightforward. And no, and do this, and hit the up arrow. And there's a question: you can have multiple distribute lists? Yes, you can, because they're calling different prefix lists. And you can type in deny. We're going to do a /32, and hit the up arrow and do a /0. There's another question: what's the purpose of the default route setup with the LA32? That's letting anything else up to and including a /32 mask being permitted out. And the idea behind that is to make sure that traffic, when it's going outbound, it's like an access list with an explicit permit. Because by default, access lists, prefix lists, and route maps have an implicit deny. It's in case you forget, it won't allow the traffic to go out. But if you do that, then you can run into problems with propagation and stuff like that. So I'm going to hit the enter key. I'm going to go back over to router 5 and hit the up arrow, and now that route it's still there. It might not have had time to propagate. Actually, you know what? I didn't even think about this. You can actually go to router 3 and type in interface loopback 100 and type in, that's what the address is, right? Loopback 100, and type in IP OSPF network is point to point, and then it'll advertise it as /24. So if we go back to 5, that route is still not being filtered, and I don't know why. Oh, there it comes into /24. Okay, so that might be part of the reason why it's not working now. So again, we're going to go back over to our prefix list and type in no, hit the up arrow, go to the beginning and 3, and then we're going to go pull it out, go to the end of the line, but we're going to type in 3.0. That's probably why it didn't work before. 24. And do show IP prefix. Let's see here. We're typing. Let's actually just rebuild it. So no IP prefix list. Prefix dash list. No out. Alright, so we're going to rebuild it. And I should only have to go up a little bit here for this other one. And this guy, and then there we go. That's what we want. So now if I go to router 5, hit the up arrow, this route should eventually get filtered, and it's just not working. Do I have the right address in there? 200. Yeah, it's the right address. Sometimes I wonder. Let's do a show run pipe section OSPF. Make sure I do show run. Make sure I have that right. Yeah, it's the right stuff. Oh, you know why? Oh, that's okay. I'm just looking at the network command. Network statement is good. Let's see. Does router 2 see it? Router 2 does see it originally. Let's see if router 2 sees it now. Should see the /24. Yeah, and I don't know why it's not filtering it based off of that. Let's see here. I just checked a quick OSPF support community on Cisco's website, and they used an access list in that. And an access list is good, but we're not trying to filter the data plane. We're trying to filter a control plane advertisement, which means that we're trying to filter a subnet, not the traffic in the path of the data. Which means that router 3 isn't actually sending us any data. We want to prevent the router 3 from advertising a route outbound. So if we look at router 5 now and do a show IP route, the route is still there. We don't want to see the route. We want the route to go bye-bye. But they use an access list, and an access list is designed to filter traffic in a data plane. You know, it can be used to do a subnet, which actually. There's a question, can you just do this? I'll do an access list just to show you guys. IP access list, we'll type in 10 just for something simple. And we're going to type access list standard 10. And we're going to say deny 10.200.3.0.0.0.255. And a permit any. Okay, now this is a standard access list, meaning it's going to go based on source-based traffic. Now I can type in router OSPF 3 and type in distribute list 10 out. Do show run pipe section OSPF. Apparently I can't use the distribute list and a prefix list at the same time. So no this guy. There we go. So now if I go to 5, the route is still there. Maybe I'm not being specific enough. Well, it's learning that. So if I type in do ping 10.200.3.3, I can ping it. If I do .2, it's not going to be able to reach it. So I might not be being specific enough, but I don't know why. I don't exactly have an explanation for you. Okay, well I just learned something that I didn't know before. When it comes to using distributed list out, works only on routes being redistributed by the ASPR into OSPF. So the distribute list command that we're doing will not work. So if we wanted to filter those routes in, we'd have to go to the individual routes, or we'd have to do a type 1 LSA filter, which I don't even think that exists. We'd have to do like an access list, but you can only do outbound. You can only do so it says use the distribute list in command in OSPF mainly. So it says the command only works on the routes being redistributed by the ASBR into OSPF. It can be applied to E2 and E1 routes, but not inter-area and intra-area routes. So I did not know that. I learned something new today. So that's a good thing to remember because I didn't realize that, which is good. So that pretty much answers that question. So, but that's how you would manipulate that. I mean, if we had an external route, we could say I could type in exit out of here and type in route, on router 3. I could make it a redistributed route by doing this. I could type in route dash map, and I could type in R3 redistribute, R3, right, not R pound, and type in match interface loopback 100, and type in router OSPF 3 redistribute connected route map R3 redistributed, and that'll bring it as a type 5 LSA subnets. And then I go to router 5 and hit the up arrow, and let's see, I did say R3 and do show IP interface brief. Our loopback 100. Yep. So do show run pipe section OSPF. So now we should have a redistribute connected in there. Yep, we do. And now we also have to type in. Now we go to 5. And why is it not propagating? I should match interface loopback 100. Loopback 100 is there. So that's right. And that's how you would set it up. You would call route map to redistribute a route in. And let's see here. That's weird. Let's do a clear. I'm not really sure. But that should actually. Let me pull that distribute list out. No distribute list there. Go to 5. Whoop. There's a question. Why do I keep going to 5? Oh, because it's internal to the network. So as soon as we let's do a clear IP route star. Yeah, for whatever reason, this is not working. But that's how you would redistribute connected subnets route map R3 redistributed. You would do a do show run pipe section route dash map. What that's going to do is it's going to call match interface loopback 0, redistribute this, which would make it a type 5 LSA, which would allow us to do our setup. But that's pretty much all there is to it. The next video I'm going to get into is breaking down. I'm going to extend the routing domain out to 6 and to 13 for both EIGRP and OSPF, and then I'm just going to do I'm going to bring the adjacencies out to 6 and 13 respectively, and then I'm going to show you guys how redistribution works on one-way versus two-way versus route feedback and all that type of stuff. Not do a ton of stuff on it. I don't think redistribution is that big of a key feature, but I don't know. I haven't taken the new exams yet. So that's pretty much all there was. The redistribution I saw in the original exam, the 642902, wasn't super bad. But then again, if you distribute list in would definitely be or distribute list out would definitely be a factor here. So I hope this has been informative for you, and I'd like to thank you for viewing.